So today we're going to be doing the synthesis of alum lab. Normally I would have you work with aluminum foil, but for the sake of time today, I'm going to be starting with aluminum powder. So the first step, it says, is to record the mass of a clean, dry beaker. So the scale is zeroed out. Put the beaker on there. And so the mass of the reaction beaker is 51.9222. Next step, it says obtain approximately 0.4 grams of aluminum foil. So if I add about 0.4 grams to that, I would expect this number to be close to 52.32. So that's how I'll know that I added enough. Okay, so that's enough. We saw nothing. Okay. 52.4066. All right. So here's my aluminum foil, or my aluminum. And we got that mass of the beaker plus aluminum. So I can calculate my mass of aluminum and my theoretical yield. Next, it says using a graduated cylinder, add 20 milliliters of potassium hydroxide to the beaker. And so that's in the fume hood. It says work in the fume hood because hydrogen gas can generate a fine mist. So we have the potassium hydroxide here, and it says I need 20 milliliters. This pump is set to 10 milliliters, so I'll need 2 pumps. Is this one different than the other one?
No, I haven't been using it a few days, so it sticks.
Oh, there it goes. One pump, 2 pump. It doesn't really matter how much we use because it's not the limiting reactant. All right, so we can see it's already starting to react. And I have a rubber policeman attached to my stir rod here, just to make it more of a scraping. The reaction will be done, we'll know the reaction's done when it stops bubbling and the liquid is mostly blackish. Okay, while that's reacting, I'm going to read the next step in my procedure. So the next step in the procedure says, when the aluminum has completely reacted, obtain 7.5 milliliters of sulfuric acid in a separate beaker. This measurement should be done in a graduated cylinder or other approximate measuring device, but never the markings on a beaker. So this pump here is set for 5 milliliters now, but I can adjust that to give me the 7.5 milliliters that it asked me for in the procedure. So that should be enough. All right, I'm going to go get another small beaker to get that sulfuric acid. Okay, so I'm all ready for the next step, but we just have to wait for it to finish reacting. It's getting close. It's one benefit of starting with the aluminum powder is it doesn't take as long as the aluminum foil. It feels really warm. So while we're waiting, you can be calculating your theoretical yield of alum and your molar masses of both aluminum and alum. The potassium, what is it? Potassium aluminum sulfate dodecahydrate. Yep, potassium aluminum sulfate dodecahydrate. The next step says using a transfer pipette, add the acid dropwise while stirring. And so I'll do that. Let's just move on. It looks pretty good. What do you think?
Yeah.
Looks pretty good? Okay. So this part's really cool looking because as we add the sulfuric acid, a solid forms. That's our alum being formed. So we made a lot of alum. That's pretty awesome. There's a little bit more acid in here, so I'm gonna go ahead and add that. All right, so these crystals here of alum are not very well formed. So what we're gonna do next is we're gonna melt this on the hot plate and then let our crystals form. So we're going to move this over to the hot plate to melt our crystals. So we don't need the hot plate very hot, so I just have it set on a fairly low heat setting. I'm going to go get my watch glass and some, it shouldn't get that hot, but I'll get my watch glass to cover it. Okay, so We have to be careful not to melt or not to boil the solution. So we're just gonna wait for the crystals to melt. And then after they're melted, we will cool them down to recrystallize our alum. We're gonna do that quickly by putting it into an ice bath, but if we let it cool down slowly over the next week, then we'd get much larger crystals. But we don't have time for that today, so we'll just be cooling it down in ice. So you can see there's still some solid, but the solution's turning a little bit more whitish tan. It was a more gray color earlier, and now it's lightened up a bit. So I can still see solid in there, so I'll give that a little bit more time to melt.
Found that once it gets a little bit hot, if it still looks like that, you add a little bit more sulfuric acid. It will clear it up.
I'm not. Well, I'm gonna get my ice bath started, or made while I'm waiting. The next step is to place it in an ice bath to let it cool. So I'll make my ice bath. So I'm gonna scoop some ice up into this beaker and then add some water to it to make it a bath. So I got my ice bath there. Move on?
Yep.
Move on. Okay. Wrong way. Turn that off. Alrighty. For the sake of time, we will move on. Give that a moment to cool on the counter. I'm not gonna let go until I know it's stable. Probably add a little bit more ice. All right, so it says to let it cool for an additional 15 minutes. So we'll try to edit this part out, the waiting, but we'll just let that sit in here. I'm gonna go get that stir rod with the policeman. this is my vacuum filtration setup. And so after we make our crystals will look like white sand. And we'll need a way of getting our crystals out. And so we have this vacuum filtration setup, and it kind of works like a coffee maker, only this time we want to keep the grinds and get rid of the liquid. So I'm going to put this piece of filter paper in here that's like a coffee filter, and I'm just going to moisten it just a little bit to make sure it sticks. So I have my deionized water bottle there. And now I've covered up all the holes with that filter paper. That's going to keep the crystals from going through the holes of the funnel. So we will be dumping this solution in here, turn on the vacuum. We won't be able to get all the crystals out at once, and so we'll be rinsing this beaker with some ice cold ethanol, which is in the ice bath over there, in order to get out the remaining crystals. But again, we're going to discard the liquid, and we're going to keep the crystals. So the crystals will start forming once it cools down a bit more. You can see it's already starting to form. If you look real closely, then when you hold it to the side, you can see more, it looks more solid down at the bottom. Those are our crystals forming. So we're gonna scrape the bottom. Oh yeah, from this view, you can definitely tell that there's a solid in there. I'm just going to scrape the sides to encourage those crystals to form. Got a lot of crystals. Okay. So since we have a lot of crystals, I'm going to say that we go ahead and move forward, even though it has not been 15 minutes. It's only been like 4 minutes. Since we haven't given it that much time, we might not get a very high yield, but that won't matter. Okay, so moving forward, we already have our 50%, well, that's 95% ethanol solution. So I'm going to use the good stuff. It calls for a 50% solution, but
we're instructors. We get to use the good stuff.
We get to use the good stuff. Okay, so I have the vacuum cracked on a little bit, and so my goal is to get out all the solid. So I'm going to swirl to loosen the crystals and then dump them out. And so you can see that there's still some crystals stuck to the side of the beaker. So that's what the ethanol is for. That is for rinsing the beaker out. Okay, so that's really cold. So I'm just going to put a splash in here. you'll use about 30 milliliters total, but that's broken up into several rinses. So dumped out some more, but there's still crystals. So try to get out some more, swirling to loosen them. Okay, so after this, whatever's left in here is just going to be left in here. I'm not going to rinse it anymore. So, last rinse. Okay, I lost some powder down in the bottom, but I'm just going to ignore that. That will also affect my yield. I'm turning on the vacuum very slowly. We want to pull air over the crystals for a few minutes to let the crystals dry. So the vacuum is pulling air from the classroom in over the crystals to dry it. And so I'm just going to let that sit here for a few minutes to dry. I'm going to read ahead in my procedure. And so we have set up the vacuum filter, we have filtered, and so we're leaving the vacuum on for a few minutes. This next step says to obtain a clean, dry watch glass. This watch glass is not dry, but we're going to need a new watch glass to transfer the crystals onto. So I'm going to go get a clean watch glass and record the mass of that. Watch glasses are called watch glasses because if you had a pocket watch, this is the type of glass that would go on top. So the scale was zeroed out. I'm going to put the watch glass on top and record the mass. The mass reads in the display 30.7327. 30.7327. So that is my mass of watch glass. All right. How does this look? I'm not a patient person. I like to poke at it. So it's a fine powder. Still feels a little damp because it's sticking to the rubber policeman a little bit. Okay, it's feeling more dry, but I'd rather let it dry here than wait by the balances and watch water evaporate. So I'd rather it spend the time here than later. Okay. Looks pretty good. I'm going to get a paper towel to put the watch glass on top of because sometimes I've been known to spill. And I like to plan ahead. Although I ripped this paper towel, so that wasn't the best in planning ahead. We'll use that paper towel for cleaning up my mess from earlier. Okay.
That's why you need a lab partner.
That's why we need lab partners. Okay, so my new lab partner gave me a new paper towel, and I'm going to turn off the vacuum. Now that I've turned off the vacuum, I can loosen this. That rubber gasket there really helped make a great seal. And now I can scoop all this out onto my clean, dry watch glass. So all of this is alum crystals. And you can tell that now that it's dry, my paper is actually so dry it's wanting to come out on its own, which is awesome. You can also make a little taco out of the paper in order to help scrape off the crystals over the watch glass. Okay, I can see some more crystals on the side of my funnel here. Scrape all that out. Okay, so I have all of my alum on this watch glass. So I'm going to walk this over to the balance in order to record the mass of the alum on my watch glass. Okay. So the balance is stable, which is a good sign. Well, it was stable. Now it's going down a bit. The mass keeps decreasing. It might still be a little damp, watching water evaporate. So I think we're a little damp still. So not much we can do about that at this point.
Let's pretend we did it right.
Let's pretend that we did it right and just write down the mass. We're going to write down a mass number of 37.6111 grams. So there you go. That was synthesis of alum.
That's called
Alum.
actual yield.
And that was my actual yield. So that's how much I actually made. So that I will be calculating, well, I'll be using my actual yield when calculating my percent yield. My percent yield is always actual yield divided by theoretical yield.